Okay, so Unit 2, Lesson 5, Literal Equations and Formulas. So in this lesson, we're going to rewrite and use literal equations and formulas. So I'm actually going to define literal equations first, because a formula is a special type of literal equation. So a literal equation it's an equation that has two or more variables. Okay, it has two or more variables. A formula is a special type of literal equation. A formula is an equation that states the relationship among quantities. So formulas, we use formulas for area, we use formulas for distance, perimeter, all kinds of things, temperature. So when we talk about literal equations and formulas, think about equations that have more than one variable, okay, comparing more than one quantity. We've only dealt with equations with one variable up to this point. So our first example here, it's about rewriting a literal equation. And it says the equation is 10x plus 5y equals 80, where x is the number of pizzas and y is the number of sandwiches. And this models a problem that we may come across later. How many sandwiches can you buy if you buy 3 pizzas or 6 pizzas? So first let's handle the 3 pizza. Let's do that first. Okay? It says in this equation, x is the number of pizzas, y is the number of sandwiches. So that means if I know 3 pizzas, if I know I have 3 pizzas, I know that x is 3. Okay? So what I can do, I can substitute 3 for x in that original equation. So that becomes 10 times 3 plus 5y equals 80. And I could solve that. So I'm going to kind of show to simplify. This becomes 30 plus 5y equals 80. And that becomes an equation I can solve. I can solve that equation by subtracting 30 from both sides. I get 5y equals 50. I can divide by 5, and then y equals 10. But it's important that we know what y stands for in this problem. Y stands for 10 sandwiches. Okay? So 10 sandwiches. So if we know the value of one of the variables, we can substitute that value in and then solve for the other variable. If I were going to do this for 6 pizzas, that would mean, in this case, x is 6. So when I substitute, that's 10 times 6 plus 5y equals 80. So that's 60 plus 5y equals 80. I would solve that by subtracting 60 from both sides. 5y equals 20. If I divide by 5, y is 4, and it's 4 sandwiches, if you can read that. So 4 sandwiches. So when I'm looking for a specific value, and I know the other value, I can substitute, and then I can solve for the variable that is left. All right? So I knew from this example, x was the number of pizzas. So it's just simple substitution and then solving, the same solving we have been working on throughout this unit. Okay? In the next example, it's a little more explicit. I'm asking you to find the value of m for different values of n. So I'm going to show you the first one, and then I'm going to have you guys kind of pause the video and try the next two values on your own. So if n is negative 2, let's just say n the way I would substitute, it would be 4 equals 2m minus 5 times negative 2, because I'm substituting negative 2 in for n. To simplify, 4 equals, this would become 2m minus negative 10, so that's 2m plus 10. To keep solving, subtract 10. This becomes negative 6 equals 2m. And to finish solving, I would divide both sides by 2. So in the end, my solution, m equals negative 3. So what you're doing is you're substituting in the given value and getting out the other value, okay? So when we're able to substitute the value in and then solve for the other variable. So right now, I'd like you to do the same for n equals 0, and then do the same for n equals 2. So this is where I'd like you to pause the video, try it, and then come back and check your solutions with me. Okay, so to continue on, solving when n is 0, I substituted in 0. I got 2m minus 0, which is just 2m. So I only had a one-step equation there. I just divided both sides by 2. I got m was 2 when n was 0. When n is 2, rather than negative 2, I got 2m minus 5 times 2, which is 2m minus 10. I solved that by adding 10 to both sides. So this became 14 equals 2m. I divided both sides by 2. I got m is 7. So what happens when we're not given a value for any of the variables? When we solve this equation for x. So this gets a little tricky. Now, these equations we get to a little bit later on. The main thing I want you guys to know how to do is to kind of think about how would we isolate x, essentially. So in this example 2 part, the first part of it, I'm going to rewrite the equation first. ax minus bx equals c. So in order for me to solve that equation for x, we've got to notice a few things. What I notice is that ax and bx are like terms, okay? So the way I could rewrite that is if I had 5x minus 4x, it would be 1x. The way I could rewrite this is I could rewrite this as a minus b times x. Because all it essentially is me subtracting those values, a and b, and then multiplying that result by x. Okay? Now, this part I want you to pay attention to closely because this is a little tricky. If we are isolating x, that means we are getting rid of this a minus b. I want you to recognize that a minus b in the parentheses is being multiplied by x. So the way I would eliminate this from the left-hand side of the equation, to undo the multiplication, I would divide both sides by this entire quantity, a minus b. Okay? Because then that eliminates that quantity. Think of the a minus b as a single number, okay? So usually you guys are used to getting a number when you solve for x. I need you to be okay with this remaining c over a minus b, okay? Because when we solve equations, we're still doing the opposite operation, that division, but we can't combine these variables, so we just keep them as c over a minus b, okay? So that one is actually I think a little bit tougher than the next one we do. So in the next one, we've got negative t equals r plus px, okay? So this one, we're also solving for x. The way I would do that is I would think I've got to isolate x, meaning I have to get rid of r and I have to get rid of p, all right? And this is very similar to other equations, except we are using variables instead of numbers, all right, instead of digits. So to solve this, the first step I would take is I would get rid of r. And the way I would get rid of r is I would subtract r on both sides. So to rewrite this, negative t and negative r are not like terms. So I would rewrite this as negative t minus r equals px. Okay? From there, I want you to think about how you'd get rid of the p there. The way I read this is p times x. So the way I would get rid of p is I would divide both sides, and I would divide this entire side by p, okay? Because when you divide something on either side, you're dividing both sides, the entire side, by that number. So in the end, I get x equals negative t minus r over p. So you will get some practice in this kind of solving. This will be fairly rare when we have to solve when it's just variables, but I want you to get the idea down that the steps are not really different, except instead of a number as our solution, it's an expression with variables in it. So I know this video went a little long for only the first half of the notes, but this is a good spot for you to stop, reflect a little bit and think about where you're at, and then go on to the next step in the lesson to help you kind of strengthen your understanding.